Hello, everyone. Okay, so last time we've learned that using sets, Lingo can model very large systems. So today I will give you more examples for LP modeling with Lingo sets. Okay, so let me share my screen first. Okay. Okay, so our first example is Auntie's kitchen problem. So Auntie's kitchen serves from 5:30 early in the morning each day until 2:30 in the afternoon. And the tables are set and cleared by buzzers working 4-hour shifts, beginning on the hour from 5 a.m. That's going to be the shift number 1 through 11 a.m. That's going to be the shift number 7, right? And most are college students who hate to get up in the morning. So Aunties pays $10 per hour for the early in the morning shift, which are starting from 5 a.m., 6 a.m., and 7 a.m., right? And $7 per hour for the others, okay? And the manager seeks a minimum cost staffing plan that will have at least a minimum number of buzzers on duty each hour, okay? So these are the minimum requirements for each hour. And you are required to formulate an LP model for this problem. So, so actually this example is very similar to the post office staff scheduling problem that we discussed earlier. So likewise, the primary decision is not how many employees working each hour, but how many employees begin working each hour, okay? Start working each hour. So with this in mind, we define the decision variable, okay? So let's see. Probably, let me open the MS Word file. Okay, let me use this screen. This one, okay. So decision variable. So let's define x of I represents the number of student employees who start working on the ith shift. Okay. Superscript. Okay. So of course, if I equals I equals 1 means beginning on the hour from 5 a.m., right? And I equals 2 means the beginning on the hour from 6 a.m. Okay. So let me copy this. I equals 3 means beginning on the hour from 7 a.m., right? And so on, right? Oh. And the last one would be the 7th shift. That's going to be beginning on the hour from 11 a.m., right? So we define these 7 variables, x1 through x7, okay? So for example, here, x1 people, those are the number of employees. Number of employees who beginning work from 5 a.m. Okay, so they work from 5 a.m. through 9 a.m., right? 6, 7, 8, 9, 4 hours, right? So actually they were gonna work until 8:59 a.m., right? So they work from 5 a.m. to 8:59 a.m. Is that correct? Okay. And let's do this. X2 people work from 6 a.m., right, to 9:59 a.m. And X3, we remove the space after paragraph. Okay, so I can have more information. Okay, yes. Screen. Okay, so X3 people works from 7 a.m. to 10:59 a.m., right? Likewise, X4 work from 8 a.m. to 11:59 a.m. X5 work from 9 a.m. to 12:59 p.m., right? X6 work from 10 a.m. to 1:59 p.m., right? And X7 work from 11 a.m. to 2:59 p.m. Is that correct? Okay. So keep this in mind because we definitely need this, okay, for our LP modeling. So what is our objective function? We are looking for minimum cost staffing plan, right? So our objective is to minimize, right? And we are going to use which information? Here. NTS pays $10 per hour for the first 3 shifts, right? And then $7 for the others. Okay. So is that going to be $10 times the first 3 shifts? X1 plus X2 plus X3. plus $7 for the other shift. So X4, X5, X6, X7. Is that correct? Almost. But be careful here. Here, Antis pays $10 per hour, right? However, each employee has to work 4 hours, consecutive hours, once they start, okay? So actually, Antis is gonna pay $10 per hour for 4 hours, right? So that's gonna be actually 4 times 10. That's gonna be $40, okay? For the first 3 shift, and then likewise, you need to multiply by 4. So 7 times 4 is gonna be $28, right? So NT is gonna pay $28 for the last 4 shifts. People in the last 4 shift, okay? So that's gonna be our objective function, okay? Subject to what? We need to consider the constraint set, right? So you have to ensure enough number of employees working each hour, right? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We have 10 blocks of time, right? So for each hour, we have to make sure we do have enough number of employees working, okay? So that's what we need to do. So for 5 a.m., so 5 a.m., who's working? Based on this, only X1 people work, right? At 5 a.m. So it's going to be X1 has to be greater than equal to this number, 2, right? So it's going to be 2. This is the constraint for 5 a.m., right? This is 5 a.m. constraint. How about 6 a.m.? Who's working? So 6 a.m., both of these people, X1 people and X2 people are working at 6 a.m., right? It's going to be X1 plus X2 then. X1 plus X2. And it has to be greater than equal to the minimum number, the number of requirement, right? Which is 3 for 6 a.m., right? So you need to keep going this. For 7 a.m., who's working? X1, X2, X3, because X1 should work from 5 to 8:59, right? X2, 6 to 9:59, and X3 start from 7 until 10:59. So all these people, X1 plus X2 plus X3, the number of people working on 7 a.m. And that number has to be at least 4, right? Based on this given information. This is for 7 a.m. So we need to keep going this, okay, until 2 p.m. Okay, so on 8 o'clock in the morning, who's working? X1, X2, X3, X4, right? 8 a.m. just keep in mind that both Lindo and Lingo are not case sensitive. So this upper class, the capital letter and the lowercase, the uppercase and lowercase are the identical. Okay, so what is the number? It's going to be 5, right? And for 9 a.m., who's working? Because X1 people work until 8:59. So X1 shouldn't be included. Okay, it's going to be X2, X3, X4, and X5. Okay, for that reason. That's going to be 3, at least 3 people, 9 a.m., right? Likewise, at 10 a.m., who's working? These 4 groups of people, X3, X4, X5, and X6, right? So X3, X4, X5, and X6, right? At least 2. That's for the 10 a.m., okay? And then it's going to be, you can imagine that, X4, X5, X6, and X7, same reason. The number is going to be at least 4, 11 a.m. Okay. This number, so let me move a little bit. Okay. And then 12 p.m. Who's working? 12 p.m. Only these 3 groups of people, right? 12 p.m. So that's going to be X5, X6, X7, at least 6, okay? 12 p.m. And at 1 o'clock in the afternoon, who's working? Only these 2 groups of people, X6 and X7, okay? It's going to be X6, X7, at least 3 for 1 p.m. Likewise, for 2 p.m., X7 is the only people working at 2 p.m., okay? So it's going to be at least 7, 2 p.m. Because here, X6 does not work at 2 p.m., right? They work from 10 a.m. until 1:59 p.m., okay? Okay, so that's all for our constraints. And don't forget to add sign restriction. So every decision variable, x of I, has to be greater than or equal to 0. And also, x of I is an integer, general integer values, right? Because you cannot hire, for example, 2.568 people, right? It's gonna be the positive integer value. So we need to add general integer restriction. For all I goes from 1, 2, 3, until 7, okay? So combining all together, yes, these are the complete LP model for the auntie's kitchen problem, okay? So Lingo, let's work on Lindo and Lingo input. So let me disable my camera so that I can show you my full screen. Okay, so here, I think these are from the last class. Okay, let me reopen. Okay, so we have Lingo. This is Lingo. So let's work on Lingo model first. Okay, let me, zoom in a little bit. And you remember Lingo always start with either min or max. Lingo does not recognize minimize or maximize, right? So, and then after min or max, you need to put equal sign before you type in the your objective function. Okay, what's going on? Okay, and you remember each statement in Lingo has to be terminated with semicolon, right? And what did I miss? Multiplication symbol. Lingo needs asterisk as the multiplication symbol. Nice thing, Lingo can recognize parentheses. So this should work, okay? But not for Lindo, okay? So this is nice. And another thing, unlike Lindo, Lingo does not recognize subject to or ST. So you need to take this out, okay? And both Lindo and Lingo, you can insert comments after the exclamation mark, okay? And the syntax aware feature of Lingo is very useful. See here, because you didn't terminate the first constraint with semicolon. You have all of this as green color, which means Lingo currently recognize all of this as your comment, okay? So you have to make sure even the comment has to be ended with semicolon, okay? So I'm gonna do this. So here, I'm gonna put semicolon. And then right before the comment, I'm gonna put the exclamation mark. But I'm gonna close the comments with semicolon as well, okay? Why is that? And I'm going to put the exclamation mark here. And do you remember both Lindo, Lingo doesn't need the non-negativity restriction. So this part can be ignored, right? And the general integer restriction for Lingo, we use GIN, right? So I'm going to put at GIN and then X1, right? I'm going to copy this. I'm going to just change this, okay? 4, 5, 6, 7, okay? And like LINGO, this general integer restriction has to be inserted before the ending mark. Okay, like that. But for LINGO, you have to include this general integer restriction after the ending mark. Okay, so that's the another big difference between LINGO and LINGO. Okay, now we are ready to run it. So I'm just press this button, and then right away we got the optimal solution. Nice, right? So this is our optimal objective function value. This is how much the auntie's kitchen will pay for. And then this is their recommended stepping plan. So they have to, we'd recommend auntie's kitchen to hire only 2 people, start working at 5 a.m. and then one start working at 6 a.m. and then 7 a.m., 8 a.m., 9 and 10. We do recommend not to hire anybody. And then 11 a.m. we do recommend auntie's kitchen to hire 1 person. Okay, at 11 a.m. Okay. Okay. Now let's work on the LINGO input. So to do that, first you need to choose options in the solver menu. And be sure to choose interface tab. And within this box, file format, you are going to choose LTX, parentheses, LINGO. And make sure apply, save. Okay. And then open the new window. Now you can see that on the top of this window, LINGO model. That is saying, yeah, it does say LINGO model. So now you should be able to work on LINGO input on this new window. Okay. So let me just copy everything from LINGO and then just paste. So we're gonna work on this. Okay. So first thing, LINGO cannot recognize equal sign in the objective function. So take this out. LINGO cannot recognize parentheses nor asterisk as the multiplication symbol. So you need to take this out. And then put this objective coefficient. Apply. Okay. Likewise, take this out. And then we're gonna multiply 28 separately, right? And LINGO does not need semicolon. Actually, if you put semicolon, LINGO will give you an error message, okay? And again, LINGO does not need semicolon, so let's take this out. You don't need to take out the semicolon in the comment section, because anyhow, regardless, Lindo take everything after the exclamation mark as the comment. So it really doesn't matter. You can still delete it if you want, but you don't need to. And instead of general integer restriction before the ending mark, in Lindo, you need to put them in after the ending mark, right? Like this. And the syntax is slightly different, right? So we're gonna take this out, and then, oh, I'm gonna just do this. Okay. I think it should work, right? Or because all of the decision variable we used in the model has the general integer restriction, you can simply count the total number of decision variable. In our case, is 7, right? So we can actually use this, okay? So if I press this, I got a error message. Why? Invalid input. Okay, let me see. Oh, you know what? We forgot to put the subjective before you type in the constraint sets. So in Lindo, you do need to include this subjective or ST. Either's fine. Okay, now it should work. See? Okay, so we got the exactly same objective function value, 384. This is how much Auntie's Kitchen will pay for. And then that's the recommended stepping plan. Okay, I think we got the exactly same optimal solution from Lindo and Lingo. Okay. Okay. Now let's work on Lingo sets. Okay, to this problem. So I'm gonna open Lingo window. So let's go back to server options. And then this time we are going to choose LG4 parenthesis extended. Okay. Apply, save, okay. And then open the new window. Now we should be able to use Lingo in this new window, because it does say Lingo model, right? So let's do that. So I'm gonna look at this. Okay. Okay, so Lingo start with model colon and end with END, right? So I'm gonna just do this. And the very first thing, we need to deal with sets section, right? So sets section always start with sets colon and end with end sets, right? So sets, let me use uppercase. So you don't need to, but I'm gonna do this. Okay, so make sure you're going to put S. Syntax aware feature is very useful again. So end set is not the Lingo function name. And sets is the Lingo function name, okay? Because we know that with this, the color is black, okay? That's gonna be your input. But whatever in blue is the Lingo function name, okay? So we're gonna use end sets, right? Okay, so first we define the sets which are needed to solve this problem, right? So let's first define the available working hours, okay? So I'm gonna put the same name, hour, and how many different hours we need to consider. There are 10 different hour blocks, right? From 5 a.m. through 2 p.m. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So we're gonna define 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Like that. Or if you want 1.10, that does work. So it's your choice, okay? So the this kitchen, Antis kitchen need employees for those 10 hours, right? From 5 a.m. to 2 p.m. each day. So we define like this. There are a number of hours, 10 different number of hours. And the set hours associates each with one quantity. What is that? That is the number of employees required, right? For each hour, right? So I'm going to use requirement. Let's say RQMT requirement. Okay, that's the one of the attribute. Okay, for our set. And the what else? The Antis kitchen plans to hire the student employees working the 4-hour shifts, right? Beginning on the hour from 5 a.m. That's the shift number 1 through 11 a.m. That's the shift number 7, right? So next we define another primitive set. Let's say, let's name it shift. Okay, and this time 1.7 because there are only 7 shifts available, right? And the set shift, the associates each with some quantities. First, the salary value, right? The cost for Auntie's kitchen. Those are these numbers, right? 40s and 28, right? So later on, we're going to provide these numbers for cost in the data section. Okay. And what else? What other attributes we need to put them in here? The decision variable, X variable. Right? So I'm going to put X here. That's the number of the student employees who will begin working each shift, right? And I think that's it, right? Next, we input the requirements and the cost for each hour, right, in the data section. So data section also start with data colon and end with end data. Okay, make sure these are all blue, okay, which are the Lingo function name. So our QMT, we're going to input the requirements. Those are the 2, 3, 4, 5, 3, 2, 4, 6, 3, 7 in order. So 2, 3, 4, 5, 3, 2, 3, 2, 4, 6, 3, 7. Okay. Oh, I forgot. You know what? I forgot to end each statement with semicolon up here, right? And here too. And we're gonna provide the cost value. So, so we need to provide 7 different values for the cost because we define here that each attribute here, cost and X, will take 7 different values, right? So make sure you're gonna provide not like this, okay? 40, 40, 40, and then 28, 28, 28. And don't forget semicolon, okay? Okay, so next, we'll create the objective function, okay, right here, by summing the product of cost and the number of workers starting work each hour. Excuse me. So it's going to be minimize equals as sum. It's going to be cost times X, right? That's the cost value, right? Times X variables, right? But in order for you to use the attribute value, last time you mentioned that, first of all, you need to specify the set name first. Otherwise, Lingo cannot recognize what this is, okay? So we're going to put shift and colon. After that, we can specify the objective function. Again, don't forget to end with semicolon, okay? Next, for each hour, right? For each 10 hours, right? For each of these 10 hours, we need to create the constraint that ensures the total number of employees working that hour has to be at least as large as the hours requirement, which are these values, right? Or right here, right? Okay, so let's do that. So at for each hour, right? So I'm gonna put hour and use subscript I, okay? for each hour, you need to sum shift. Let's use different subscript J and XJ has to be at least as large as the hours requirements. So RQMT requirement I. Okay, and then just make sure we're gonna match parentheses. So see here, we have red color, and then up here we also have red color there. Okay, and then end the statement. So is this correct? For example, if you want to see what we created so far, then go to generate and display model. So this is what you've got so far. Okay, based on our Lingo set, Lingo generate these constraint sets. So is this correct? Obviously, no, that's not correct, right? You should include a restriction, right? So that only the people who belongs to that hour, each hour, does work. So only the people who belongs to this hour does work each hour. So you need to include the, what is that? The conditional qualifier that we discussed last time, right? So just like we did for the post office staff scheduling problem. So make sure the first constraint, the left-hand side, only include X1 instead of X1 through X7, right? And even the second constraint, we're going to make sure that only X1 and X2 will be included in the left-hand side of the constraint, right? Not like that, okay? So let's work on that right now. So I'm going to use word file again, and I'm gonna have the new page. Okay, so I'm gonna use this screen as of now. Okay, so like we did, let's see. Okay, here's pen, or I can actually write down. That's fine. So at 5 a.m. So I mean I equals 1. Okay, if I equals 1, so we are considering at 5 a.m. we want to know who is working. Who is working? That's my question. So at 5 a.m., only people who start working at 5 a.m., right? They are X1. So the answer is X1, right? So here we take the subscript value J has to be equal to 1 if I equals 1. Okay, is it correct? So we take J equals 1 from the subscript. So my question is how to get j value, which is equal to 1. If we put the constraint restriction, j equals I. Okay, so in this case, I has the value of 1. So if we include this condition, then j will take the value of 1, right? How about at 6 a.m.? So now I'm talking about I equals 2. Then who's working? Now, from here, we know that it's going to be x1 and x2 people, right? So that's going to be x1 and x2, right? So in this case, j should be equal to 1 and 2. So this condition doesn't work anymore, right? So we need to make revision for that. How? J, what if j is less than or equal to I? So that j can take both values, 1 and 2, right? Because I, the current value of I is 2. So if j is less than or equals to 2, then it's going to be 1 and 2, right? How about at 7 a.m., which is I is equal to 3. Who's working? x1 plus x2 plus x3. From here too, right? At 7 a.m. So this condition still works, right? J is less than or equal to 3. In a way, j can take 3 different values, 1, 2, and 3. If j is less than equals I. Okay. Let's continue on this at 8 a.m. So I'm talking about what if I takes the value of 4? Who's working? Be x1, x2, x3, and x4, right? So this condition still works, right? In a way, we have these 4 different values, right? How about at 9 a.m.? That is, I takes value of 5. Then who's working? 9 a.m. X2, X3, X4, and X5. These are the only people working at 9 a.m., right? So from here. So here we specify X2, X3, X4, X5. Now, with this condition, we have this, right? The current value of I is 5. So if we use j is less than or equal to I, then we're going to have 5 different values. However, at 9 a.m., x1 people doesn't work anymore. So we shouldn't include this, right? So how do you do that? You need to add one more constraint then, one more restriction. So how about j is less than equal to I, and j is also greater than equal to, let's say, I minus 3. So I is 5, 5 minus 3 is 2. So j is greater than equal to 2. By adding this restriction, j can take only these 4 different values, right? Can you still use this condition at 10 a.m.? I equals 7. Who's working? X3, X4, X5, and X6. Yeah, in that case, 3, 4, 5, 6, right? And these two conditions are still valid. How about at 11 a.m.? I equals 7. Then who's working? X4, X5, X6, X7, right? So in that case, J takes 4 different values, 4, 5, 6, and 7. So this condition still works. Now let's move on to noon at 12 p.m. So if I takes value of 8, who's working? So we are talking about noon here. So only 3 groups of people, X5, X6, and X7s are working, right? At 12 p.m. So in that case, the question is, if these conditions work, okay, so with these two conditions, what values j can take? First, j is less than equal to I is equal to 8. So it's going to be 1, 2, 3, 4, 5, 6, 7, 8, right? And then j has to be at least I minus 3, which is 5, right? 8 minus 3 is 5. So j has to be greater than equal to 5. So we're going to take this out, right? So with the current conditions, j can take these 4 different values. But the thing is, we don't have 8th shift. So do we have to add one more condition to exclude this last number of 8? Actually, no, you don't need to. We don't need to add another constraint for that, because what is the LINGO model? Okay. oh, okay, back here. So in our lingo sets, because lingo already know that J can take only 7 different values, which is 1 through 7 up here, because that's the way how we define the set shift, right? So I believe these two conditions are still valid, okay? So lingo automatically take out the last value of 8, okay? Okay, so let's move on to the next shift. So just to let you know that regarding this, the information, whatever the information you defined in the set section has the first priority, okay? Which means that Lingo always remember all of this information that you defined in the sets section, okay? So whenever there is an additional information that violates the information you defined in the sets section, the Lingo will ignore, okay, the new information automatically. Okay, so let's move on to 1 p.m. So what if I takes the value of 9? Then who's working? It's going to be x6 and x7, right? From here. So in that case, J only takes 6 and 7, okay? And this condition still works, okay? Still valid. So finally, for 2 p.m., that's our last time window. I equals 10, then who's working? X7, okay? The last one here, X7, people only. So J takes single value of 7, and we use the same constraint set, okay? Okay, now we need to add this conditional qualifier to the current Lingo input. So we're gonna input this condition, okay? Where? Right after here. We're gonna put the vertical bar and then include that condition, okay? And we will use the Lingo syntax. So I'm gonna do this. J is greater than, or actually J is less than equal to I, right? So J is less than equal to I. So I included it here. So I'm gonna take this out. And right? So I'm gonna take this out. Again, J is this time greater than equal to I minus 3. So I can take this out, right? I already included. Okay. So I believe Let me just double check what we did is correct or not so far. So under the server, generate display model. Something's wrong. Okay, there's a syntax error. 12. Okay, for hour and assume shift J, J. I don't know why it has. Let me just write down the same font. I don't know whether it's going to be the problem. And J is greater than equal to y minus 3. Okay, let's try again. Oh, okay, so it's not the font problem, of course. Okay, let me see where we made mistake. Okay, I got it. So greater than equal has to be GE, not GR. So I think it should be okay. Okay, right now, I didn't mean to solve the problem, but I want to see the constraint sets. Okay, so based on our Lingo set, this is what Lingo generated for our constraint. So the first constraint, x1 is greater than equal to 2. And second constraint, x1 plus x2 is greater than equal to 3. Okay, so looks like everything looks okay, right? Okay, now let's get back to our Lingo set program to complete. So what is currently missing? Okay, we forgot to include this general integer restriction, right? So actually you can just copy this and paste. That does work. But let's use @4 looping function, okay? So that instead of explicitly mention this 7 times using @4 looping function, and it's going to be shift, right? I only one expression. You can complete that. Okay. Match. Okay. So if I press, oh, I missed the parentheses. Okay, now it's matched. Okay, should be okay right now. Okay, so now we have the exactly same objective function value, right? $384. Oh, and here, yeah, this is the optimal solution value, X values, right? So I believe those are identical. Same optimal solution value we've got from both LINGO, and LINGO sets. Okay. Okay. Okay, so what's next? Let's go back to our slides. Okay, so this is our first example problem. So with this example, we've seen that LINGO enables us to create how many constraints? To create, 10 constraints, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 constraints, right? 10 constraints by typing just one line here. Just one statement, okay? This is because LINGO, in this case, allow us to group the similar objects together into the sets, right? In this example, such group would be the hours, right? Okay, so let's consider the next example problem. This one. Okay, so this example problem has been extracted from the other operations research textbook. I believe is Hillier Lieberman's Introduction to Operations Research book. So in this example, university maintains a powerful mainframe computer for research use by its faculty, PhD students, and research associates. And during all working hours, an operator must be able to operate and maintain the computers, as well as to perform some programming services, okay? And the director of the computer facility oversees the operation. And this is now the beginning of the fourth semester. And the director is confronted with the problem of assigning different working hours to her operators. Okay? And because all the operators are currently enrolled in the university, they are available to work only a limited number of hours each day, as shown in this table. Okay. And there are 6 operators, 4 undergraduate students and 2 graduate students. Okay. And they all have different wages rates because of differences in their own experience with computers and in their programming ability. So basically, this table shows their wage rates, right? Here, along with the maximum number of hours that each can work each day. So these are all the maximum number of hours available. And also each operator is guaranteed a certain number of, certain minimum number of hours per week that will maintain an adequate knowledge of the operation. And this level is set arbitrarily at 8 hours per day. 8 hours per week, sorry. And for the undergraduate student, and the undergraduate students are identified as the KC, DH, HB, and SC, and 7 hours per week for the graduate student. Those are KS and NK. So these first 4 students are the undergraduate students, and these 2 students are the graduate students. Okay. And the computer facility is to be open for operation from 8 a.m. to 10 p.m. Monday through Friday, with exactly 1 operator on duty during these working hours. Okay. And on Saturdays and Sundays, the computer is to be operated by other staff. Because of a tight budget, the director has to minimize the cost, and she wished to determine the number of hours she should assign to each operator on each day. Okay, so again, you are required to formulate a linear programming model for this problem. And I already provided the decision variable. Okay, so I want you to use x of ij as your decision variable that represents the number of hours operator I is assigned to work on day number j. Okay, and also I provided 4 different sets of constraints you need to consider while building up your LP model for this case. Okay, so let's build the LP model then. Okay. Again, I'm going to use Word file. Okay, and I'm going to insert a new page. And I'm gonna move a little bit here. Okay, so let's work on this. Okay, so first I'm gonna restate decision variable. X sub ij is the number of hours operator I is assigned to work on day j. Okay. I. So we have how many operator? We have 6 operators, right? So I will be 1, 2, until 6, right? So where 1 equals KC, 2 equals DH, right? And so on. And 6 equals NK. From this table, okay, in order. It's going to be I. And the J values, how many different J we have? How many J values? J is going to be 5 different values, right? Because there are only 5 working days in a week, Monday through Friday, right? In here, Monday through Friday. So it's going to be 1, 2 to 5, right? So of course, 1's going to be Monday, 2's going to be Tuesday, and 5 is going to be Friday. Okay. So that's our decision variable. Now we need to consider our objective function. We want to minimize, right? We minimize the stepping plan. So it's going to be minimize, and we are going to use these wage values, right? So that's going to be basically $10 times what? X11 plus X12 plus X13 plus X14 plus X15, right? And $10.10 times X21 plus X22 plus X23 plus X24 plus X25 and so forth, right? You're going to do that until $11.30 times X65, right? So let's do that. It's going to be X11, right? X12, X13, X14, X15, right? That's for the first operator, KC. But, you know, because the wage for Tuesday and Thursday for operator KC is going to be 0. That means he doesn't work, right, on Tuesday and Thursday. So you don't need to include X12 and X14. Is that correct? Now let's move on to operator DH. DH, you're going to pay $10.10, right? Likewise, you don't need to include 2-1 and 2-3, right? Because he's not going to work on Monday and Wednesday and Friday as well. So we'll only include X22, X24. That's it for DH, right? So continue on for HB. So $9.90. That's going to be wage per each hour. This time X31, 32, 33, and 35, right? 31, 32, 33, 35, right? So let's keep doing this. 9.8. X41, 42, 43, 45, right? Same. Okay. And for KS, $10.80 times X51, X53 plus X54. And finally, NK, 11.30 times X65, 64, and X65, right? Is that all? Okay, that's our objective function. Okay. Okay, so what's the first constraint we need to consider? Okay, the first constraint we're going to handle is going to be maximum number of hours available each day. Okay, that's very straightforward and very easy because here, this table provides all this information, right? these values shows the maximum hours availability for each operators for each working day, right? So first constraint, I'm gonna just write it down. Okay, let me just copy from here. So the first constraint, I'm gonna use asterisk. So that's the comment. Likewise, I'm gonna put asterisk. Okay, so our first constraint is basically x11 is less than equals 6, x13 is less than equals 6, x15 is less than equals 6, right? And then x22 is less than equals 6, x24 is less than equals 6. Continue on that. x31 is less than equals 4, x32 is less than equal to 8, right? And then you need to do that all the way down to x64 is less than equal to 6. And finally, x65 is less than equals 2. So you need to put them in here, okay? Everything. x11 less than equals 6, x13 less than equal to 6, x15 less than equals 6, all the way. x64 less than equal to 6, and x65 less than equals 2. Okay, that's what you need to do for the first constraint. Now let's work on the second constraint. Number of hours guaranteed for each operator. Okay, I think if you move down to, okay, second screen here. Okay, down here, we need to consider this information, okay? So for the undergraduate students, KC, DH, HB, SC, the minimum number of hours per week, the working hours per week has to be 8 hours, right? So for example, for KC, how'd you do that? So if you look at the KC, is the undergraduate student. So x11 plus x12 plus x13 plus x14 plus x15 has to be greater than equal to 8 hours per week, okay? So for KC, it's going to be x11, x12, x13, x14, x15 has to be at least 8 hours per week, right? However, just like we did for the objective function, we don't need to include x12 and x14 because from here we know that KC does not work on Tuesday and Thursday, right? So these are redundant information. So just take this out. Okay, so that's for the KC. If you move on to DH, it's going to be x22 plus x24 is greater than equal to the same number of hours, 8 hours, right? So x22 plus x24 has to be greater than equal to 8. So you need to keep doing that. Okay. But for the graduate student, KS and H, you have different number, right? So for KS, it's going to be X51 plus 53 plus 54 has to be greater than equal to 7 instead of 8 hours per week, right? So it's going to be X51, X53, X54 has to be greater than equal to 7. Likewise, NK, another graduate student, X64 plus X65 has to be greater than equal to 7. Okay, so these are the second set of constraints. Then how do you deal with the next constraint? Total number of hours worked each day has to be equal to 14. 14. Okay, so what is that? So how many constraints we're going to have for this condition? 5 different constraints, one for each working days, right? So for Monday, what you need is X11 plus X21 plus X31 plus X41 plus X51 plus X61 has to be 14. Is that right? So we're gonna put them in here. X11 plus X21 plus X31, X41, X51, X61 has to be equal to 14. That's for the Monday constraint. But again, wherever there is a 0 value, we don't need to include this, right? Because we know that DH doesn't work on Monday and NK doesn't work on Monday. So you need to take out X21 and X61, right? So likewise, you can construct one for Tuesday, Wednesday, Thursday, and Friday. So let's do it for Friday. Okay, so it's going to be X16, right? Sorry, it's 15, right? X15 plus X35, X45, X65 is equal to 14. Okay. And last but not the least, we need to add non-negativity restriction. So Xij is greater than equal to 0 for all I and j values. Okay. So combining all together, this is the complete LP model for this example. Okay. Okay, so right now, let's work on LINGO sets. Okay, because Lindo and Lingo without sets would be really straightforward. But let's practice LINGO sets with this example. Okay, so I'm gonna use this, but besides the Lingo window, so that I can still reference what it did for LP model. Okay, from here. Okay, I'm gonna open the new window. Okay, so we have new Lingo window. Oh, it's very dry. Okay, let me drink water. Okay, so Lingo start with model and end with ending mark. So I'm gonna just put this. And as always, we start with defining sets in the sets section. So sets and end sets. Okay, make sure all of these are in blue so that they are the Lingo function name. Okay. So in the sets, first we define, let's define the operator. Okay. So, okay, I'm going to use uppercase operator. And how many operators do we have? We have 6 different operators, right? So after slash, you can use 1, 2, 3, 4, 5, 6, or simplify this 1.6, or you can explicitly specify that. So go back to slide, and then I'm going to specify the operator's name. Okay, KC, DH, HB, SC, KS, and K. That does work. Okay. And after colon, we need to specify the attribute. Okay. So let's look at the model. So, okay. First thing, the set operator associates with the wage, right? Wage rate, the pay rate. And what else? And the minimum number of hours guaranteed, right? Those are the 2 different numbers, kind of numbers. 8 for the undergraduate student and 7 for the 2 graduate student, right? So we need to have those 2 attributes. So let's say minimum wages, but you cannot use min because it's in blue. That means min is one of the Lingo's function names. So let's say minimum instead. Okay, minimum, and let's say pay rate. Okay. Okay, and what else? We need to define another set. What is that? Day, working day, right? And there are 5 working days in a week. So this time, Monday, Tuesday, Wednesday, Thursday, and Friday. Okay. And the set day associate each with one quantity. What is that? The total number of hours, right? Worked each day has to be 14. So each day, the total number of working hours is set to 14. So we have to put them in here. So let's say that's the required working hours. Okay. Okay, so is that it? So far we defined two different primitive sets. One is operator, because there are 6 different operators. We have 6 members in the member list, right? And the set operator associate each with these 2 different quantities, right? Pay rate or wage rate, and the minimum number of hours guaranteed for each operator. So we also name it minimum, okay? And we also define another primitive set, day, because there are 5 working days in a week. We have 5 members in the member list. And also this day associate each with the one quantity, because each day the total number of working hours is set to 14 hours from 8 a.m. to 10 p.m., right? So we just named it as required. Okay, so is that all? We actually need one more set to input the assignment, okay? We need to assign each operator to each working day, right? So we need a 2-dimensional table defined on the operators and the days, right? Just like we use in this table. This is 2-dimensional table, right? So in this case, we need a derived set, okay? So let's name it assign. And this assign, this derived set has 2 attributes, actually, okay? And this derived set is coming from parent set, which is operator and day. And what attributes we have? One is available. That represents the maximum number of hours that each operator can work on each working day, right? That refers to these, right? These values. Also, the other one is our decision variable, right? So our decision variable is the number of hours operator I is assigned to work on day J, okay, for example. So I believe that's it for the defining the set, the set section. Now we move on to the data section. And we provide the data values, okay? So we need this, right? And we also need this, right? And we need this too, right? So for the minimum value, it's going to be 88877, right? So for the 4 undergraduate students, 8, and 2 graduate students. The value is going to be 7, right? And the pay rate, we're going to put these 6 different values in order. 10, 10.10, 9.9, 9.8, 10.8, 11.3. Don't forget to close each data value with semicolon as well, and up here as well. Okay, just be careful. Okay, keep in mind that in Lingo, each statement has to be terminated with the semicolon. Okay, and the required, okay, it's going to be 14 for each day, right? And the available, that's going to be all of these table values, right? So let's put them in here. So available is going to be 60606. Actually, you can put 06060 and 48404. But for the easier readability, I'm going to just sort it this way. Okay, but you don't need to. And what is the next column? 55505 30380. And finally, last row 00062, and then semicolon. Okay. Okay, now we are ready to work on our objective function. Okay. So for our objective function is this, right? This is the objective function. So it's going to be minimize okay. Don't forget equal sign before you type your objective function. Okay. So you want to minimize the total payment, right? So it's going to be, what do you call it? Total pay. And then total pay would be equal to, and something like that. Or you don't need to do this, right? Directly you can put the summation sign over there. Summation symbol, I mean. And your objective functions gonna be basically pay rate I times X ij, right? So pay rate is those 6 different values and X ij values. So that's what you need basically. But you remember, for you to use these attribute values, right? Pay rate and X variable, you need to specify the send name first. Okay. So in this case, we just need to include a sign. Because in this assign, the same name assign, the operator is already included, right? That's for pay rate. So what you need is include assign inside the parentheses, you just specify subscript ing, like that. And then don't forget to close parentheses. That's it, right? So right now, let's check if the Lingo generate the objective function. As you planned for. So choose display model, something like that. How's that? This what you are looking for? That's okay. But the thing is, Lingo does include actually it's okay. So it's going to be, well, it's hard to see. I use the numerical value here, but I use the actual operator's name and the actual working days. So it's going to be 1, right? It's going to be x11 and x13, I believe. And no, actually it's x12, right? And x13 and x14. Okay, so okay, that's okay. That's good. That's good. So that I want to include conditional qualifier, so that in our actual formulation you do not include this x12 and x14, right? Because it's redundant information, right? Because we know that the first operator, KC, does not work on Tuesday and Thursday, right? So let's not include this in our formulation. So in the Lingo set, what you need is right after this, okay? Right after this name, assign, you need to put the vertical bar. And I just say the available ij is not equal to what? Value of 0, okay? So let me press enter, so you're gonna see that, okay? So now let's see how Lingo generate our objective function. Okay, so this is our new objective function. So compared to the previous one, right now, KC, for KC, there is no Tuesday and Thursday, right? So that's what exactly what you're looking for. Okay, sounds good. So let's get back to our Lingo set. Okay, so it looks like our objective function is done, right? And let's now work on our first constraint set, okay? So first constraint set, so let me copy what it did earlier from regular Lingo, not the regular Lingo, just LP modeling. So I'm gonna just copy paste here. Right now, you can see that everything that I pasted here is in green because Lingo take it as the comments since is after exclamation mark, right? Is that? Where is our Lingo model? Okay, so here. So now we're gonna handle that. So after that, just put the semicolon. And now we are going to handle our first constraint set. So that's going to be, let's say, 4 each day. So J, right? We're going to no. Actually, in that case, we have to use the assign, right? So assign ij, right? X ij is less than equal to available, right? Is that correct? aj. That's it, right? So again, what you need is this, right? Which is exactly the same as this, right? Each xij values has to be less than equal to whatever is available. Okay. However, in order for us to use this available attribute, available and x value, you need to specify is the name first, which is assign. Okay. So that's why we did it here. So let me delete this and let's check if Lingo generate the constraints correctly. Okay, so that's what Lingo generated. Again, you can see that there is some constraints, unnecessary the constraints has been included, right? So, you know, KC doesn't work on Tuesday and Thursday, but it's been included here in the model. Actually, you still can include it, but there is no point to include those, right? It will just increase the size of the problem, the LP model. So I don't want to do that. So like we did earlier in the objective function, what you need is just include this part. Just include this part, right? So right here, after the vertical bar, you need to include this, okay? I'm gonna put down here so that you can see everything clearly. So let's see. Let's regenerate our model. Okay, right now, okay, so if the operators are not available for certain days, then the corresponding, the referencing assignment has not been included here, right? So I think we are on the right track right now. And now let's move on to the next constraint set. Okay. So for each operator, right? Next constraint has to be for each operator. Let's say I. Oh, sorry. We need to sum x ij has to be greater than equal to, what is that, the minimum, right? Minimum requirement, minimum. So those are these values, right? Something like that. We need to match the parenthesis. Oh. So, oh, this doesn't match to this, right? Okay. I think, oh, I missed here. It's gonna be here. So that this parenthesis does match this. Okay. So I'm gonna delete this. And again, like we did earlier here, I want to add this logical expression. After the vertical bar, right? So in a way, we can avoid defining and also referencing the assignments in which the operator is not available, right? So I just want to make sure LINGO does generate the constraint set as we planned. Oh, it have. Oh, okay. So what is the problem? We didn't specify the set name here, right? So it's going to be day J. And actually, you need to put this condition right here, right? Okay. So did I get it correct? Okay, I forgot. Column mark here. Let me double check. Parenthesis, that's match. That's match. Okay, let's try again. Choose the display model. Okay, let's see Is everybody looking for? Yes. Okay, so we have 6 constraints according to 6 different operator, right? And then last 2 operator, those are graduate student. So they do have 7-hour requirement. Other 4 undergraduate student has 8-hour requirement. Okay, and that looks good. Okay, now let's move on to this third constraint. Total number of hours worked each day is 14. Okay, so this time, so instead of operator, we're gonna do this at 4 each day, right? This time. And as sum, this time operator instead of day, right? So we just swap here, down here. So here we have operator I, okay? And after the vertical bar, again, you're going to include this logical condition, right? And then x of ij has to be equal to, what is that? Required j. So this parenthesis match, right? And this match as well. Okay, and then we are going to delete this. So let's double check, generate our math model. So right now, we just added these 5 constraints for each working day, right? So that looks good so far. Okay, now we need to handle this non-negativity restriction. Actually, we don't need to, right? Because both LINGO always assuming that all of the decision variable included in the model, so non-negative, okay? And also takes the real values unless specified otherwise. So I think that's all, right? So let's run the program. So we got the solution, okay? That's the optimal objective function value. And our optimal solutions all the way down here, these are the x values, right? x11 has to be equal to 2. x12 is 0, of course. x13 is going to be 3, right? Things like that. Okay, so these are our optimal solution value. And later on, when you are talking about the sensitivity analysis, we are going to talk about the reduced cost and also dual prices. Okay, so don't worry as of now. Okay. Okay, so I think that's it. That's all for today. Okay, so I'm hoping that as of now, all of you have some better idea to use both Lindo and Lingo, and even using Lingo sets, okay, to solve any linear programming models. Okay, so hopefully later on for our homework assignment and even for our term project, you can use these optimization solver packages. Okay, thank you very much. So I will see you next time. Bye-bye.